So now let's learn how to create triglycerides, because really, honestly, the majority of fatty acids are not floating around by themselves, whether they're in your food or in your body. Fatty acids are hooked up to glycerol to form triglycerides or triacylglycerols. All right, do you guys remember glycerol from back in the alcohol chapter? It was 1,2,3 propane triol. It was a 3-carbon alcohol with 3 OH groups. So we're going to draw glycerol like this, just vertical like this. Remember back in the alcohol chapter, we had it horizontal. So this is glycerol. And then we're going to draw 3 fatty acids, and we're going to esterify, make an ester bond between the 3 fatty acids and glycerol. If you have 3 different fatty acids, you create something called a mixed triglyceride or a mixed triacylglycerol. If all 3 fatty acids are identical, they're the exact same one, then it's called simple. So simple is the same fatty acids. All 3 are the same. Mixed, different fatty acids. Okay? So let's say we're going to do a mixed triglyceride. So I'll do maybe this fatty acid here. It happens to have 12 carbons, so that would be lauric acid. And let's say over here, I happen to have this one. It's got 18 carbons, and it looks saturated, so that would be stearic acid. And then let's say this one, I throw in an unsaturated fatty acid. Let's say I've got 7, and then here's 9, 10, and then 9, 10, and I put 6 more. No, I don't want that. I want 5 more, and then a CH3. So now we have a total of 16 carbons with 1 double bond between carbons 9 and 10. So this would be palmitoleic. So this is lauric, this is stearic, this is palmitoleic. I just decided on 3 different fatty acids because I wanted to create a mixed triglyceride. Like I said, if all 3 are the exact same thing, like lauric, 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 or stearic, 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 or palmitoleic, 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 then it would be called a simple triglyceride. Okay, so you guys remember esterification from back in the carboxylic acid ester chapter. Esterification is a reaction between carboxylic acid and an alcohol to create an ester bond. And remember what we did? We removed an HOH. So we're going to remove an HOH. And we're going to create the ester bond. Here we go. Carbonyl O, carbon, carbonyl O, carbon, carbonyl O, carbon. And you've got 3 ester bonds. And that's why triglycerides are considered saponifiable lipids, because they have ester bonds. And if you have an ester bond, you can make a soap, or you could do saponification. All right, quick question here. Do you expect to find this triglyceride in a solid fat or a liquid oil? Remember, liquid oils have more unsaturated than saturated. Solid fats have more saturated than unsaturated. You find both types, but since over here you've got 2 saturated and 1 unsaturated, probably this would be found in a solid fat. Okay? All right, so that's a triglyceride. So sometimes what they'll do is they'll do a triglyceride like a generic one. They'll do the 3 carbons and then carbonyl, and then they'll say R1, R2. So think of it as like rest of the molecule, R3, just generic, no details, just to show that this is like a general formula for a triglyceride, a mixed triglyceride, because the 3 R's are different. All right, good. So that covers how to draw a triglyceride. We're ready now to go ahead and do some chemical reactions. Hydrolysis, saponification, hydrogenation, oxidation, I'll just mention briefly, but let's first talk about hydrolysis. All right, hydrolysis of triacylglycerols. Hydrolysis. Remember from the carbohydrate chapter, the term hydrolysis means break apart, lyse using water. But you can't just use water, you need to always have a catalyst. So when you're hydrolyzing, great phone, let's just turn this off. Okay. There we go. All right. When you're hydrolyzing, like I said, you need water and you need some type of catalyst. So we're going to write plus water. And since you've got 3 ester bonds, we're going to say 3 waters. Think of water as HOH. And what you're going to do is just break the ester bonds. Just, that's it, chop, 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 and you end up with the original fatty acids and the original alcohol. And the original alcohol is glycerol. I'm going to do the arrow over here. Now, 2 ways you can do this. You can use the enzyme lipase. That would be your catalyst, lipase enzyme, or acid plus heat. Okay, either one will be enough to break those ester bonds. So what do you end up with when you do this? You end up with glycerol plus 3 fatty acids. That's the product of the hydrolysis of a triglyceride. So you end up with the original, so this is broken. This ester bond is broken when you hydrolyze, and you end up with an H here, H, OH. Okay, the original 3 fatty acids and the original glycerol. That's hydrolysis. All right, what is saponification? Saponification, if you remember from back in the ester chapter, carboxylic acids and ester chapter, we're going to do that. So I'm going to start off with my triglyceride. This is my triglyceride, and I'm now doing saponification. So hydrolysis is basically breaking it, and you can use an acid catalyst, but saponification, you're breaking it, but you have to use a base. So some strong base like sodium hydroxide or potassium hydroxide. Have you heard of lye? Like in the olden days when they used to make soap, they had lye. Well, that's your sodium hydroxide. All right, so saponification, you need sodium hydroxide, aqueous, in water. Okay, we're going to put 3 of them. So we're going to need this with aqueous sodium hydroxide. It's actually a 2-step process, but I'm going to show you how it looks at the end. All right. You end up breaking the ester bond, and this is what it starts, what it looks like. You end up with glycerol again. So back to glycerol. But now, instead of the original fatty acids, look at what we've got now. We have fatty acid salts. Okay, here we go, O minus, sodium plus. So you have 3 fatty acid salts. So the result of saponification, you end up with glycerol plus 3 fatty acid salts. And these 3 fatty acid salts, if you've got a long fatty acid, it's called soap. They are called soaps. Remember, we never called them soaps back in the carboxylic acid chapter. When we did saponification of esters back then, we just said that, okay, we have a salt. But now, if you've got a long chain fatty acid and it's got a charge to it, so it's a salt of a long chain fatty acid, you now can call it a soap. And this would be called sodium laurate. It might be an E here. Yeah, sodium laurate. And this one would be, the second one would be sodium stearate. Look at your labels of soaps and shampoos. You might see that sodium stearate or sodium laurate in them. And this one, there's not much room here, so I'm going to erase because everything looks too cluttered. This one would be sodium palmitoleate. Again, like I said, if you look at the labels, you see sodium oleate, sodium laurate, sodium palmitate, sodium stearate. You might see sodium palmitoleate. These are names of the different soaps or the fatty acid salts. Okay, so we'll do the other reactions in the next video. And oh yeah, and we'll talk about how soaps work.